Okay, so a little practice. This was the quiz, I think, from last year. So I'm just going to do it. You definitely get a little practice from this. Here we go. And I'm still coughing. So if you hear me coughing, I apologize. All right, so this one says use substitution. Okay, so when substitution, you want to rewrite one of the equations if it's not already given to you in terms of y. I'm going to keep the first one, so let me call this 1, let me call it 2. I'm going to keep the first one, and I'm going to change the second one. So the second one says 5x plus y equals negative 13. So I'm going to change that so it's y equals something, right? So I'm going to write it in terms of y. So in order to do that, well, y in the middle, I'm going to subtract 5x from this side, and I'm going to do 5x on that side. That goes away, positive y comes down, and I'm going to write negative 5x minus 13. So that's my the first thing I do. So this equation, I'm going to rewrite it. It's the same thing as that. Okay, so one of your two equations, right, has to be in this format. Now I'm going to, so now we know what y is. Y is negative 5x minus 13. So I can take this, right? They're telling me what y is, and I'm going to take this and put it over here. So if I place it, so if I take the second equation, which is 6x plus 6y equals negative 6, and I replace the y here with this negative 5x minus 13, I will have an equation with one single variable, which I can then solve. So 6x plus 6, and instead of the y, I'm going to replace it with, put in parentheses, negative 5x minus 13 equals negative 6. Now it's just, I really don't have to go through this, and you just gotta solve it. So 6x, security property, minus 30x, what is this? Minus 1878 equals negative 6. We can combine like terms, I combine these two. I get negative 24x minus 78 equals negative 6. Two-step equation, so let's do plus 78 on both sides, lie in the middle. And let's see, this goes away, negative 24x comes down. And this looks like 72, positive 72. Divide by negative 24, divide by negative 24, and x equals negative 3. So now I know what x is. Right, so now I'm going to take this, whatever x is, and I can choose any of these three equations, plug it in, and find out what y is. So I'm going to take this equation, right, this one, the second version of the second equation. Y equals negative 5x minus 13. I know what x is, it's negative 3, so over here, I'm going to replace it. So I get y equals negative 5 times negative 3 minus 13. Y equals negative 15, sorry, that's multiplication, 15, positive 15, minus 13, and y equals 2. So my answer is point negative 3, negative 2. So for Monday's test, this is not your final thing. You actually have to come and check. Right, so we know the answer. So there's these two lines, right? So if you were to graph it, don't pay attention to my graph, but if you were to write this two lines, right? One going like this, one going like this, and they meet somewhere over to, oh, sorry, let me make it a better representation. They meet somewhere over, and again, this is just they meet somewhere over here, right? The intersection of the two lines is a solution to both equations. So I'm going to check. So I'm going to take the equation 1, which is 6x plus 6y equals negative 6. And I'm going to substitute negative 3 and 2 to see if it really works. So this is x and this is my y value, right? So instead of x, I'm going to write negative 3. Instead of y, I'm going to write 2. So I get 6 times negative 3 plus 6 times 2 equals negative 6. 6 times negative 3 is negative 18. 6 times 2 is 12, and you can see that it is indeed equal to each other. So it worked for the first equation. Now I'm going to do the same thing for the second equation. It doesn't matter which one you choose, whether this one or this one. They're both the same thing. So for the second equation, I get 5x plus y equals negative 13. So let's, again, substitute. Replace x with negative 3 and y equals 2, and hopefully it gets negative 13. So 5 times negative 3 plus 2, right, equals 13. 5 times negative 13 is negative 15. Plus 2 equals 13, and you can see, so negative 13, forgot the minus here. And you can see that both sides equal each other. So this point here, negative 3, 2, is a solution to both points. This is all what you have to do, substitution. So remember, substitution, we're replacing, right? We're writing one equation in terms of y if it's not already given to you. And then you're going to replace that part in the other equation, right? So that you only work with one variable, find the value for one of your letters, one of your variables, right? And once you find that, go back to the other equation, replace the value for x or y or whichever one you found, find your other value, and that's your answer. Don't forget to check. But this is substitution. And then you'll have a question on, what is next? On elimination. Elimination is the easy one, right? So again, remember, we want one of the two variables to be the same, so you can add or subtract one equation with the other. So in this case, it doesn't matter what you pick. Pick either you want to get rid of the y's, or the x's. I'm going to pick, let's get rid of the x's. So 5 and 3, these common multiple is 15, so I'm going to make both of them be equals 15. So I'm going to multiply this first equation here by 3, and I'm going to multiply the second equation by 5. So if I do that, so right, so everybody gets multiplied by 3. So let's do that. 3 times 5x is 15x. 3 times 4y gives me 12y. And 3 times negative 14 is negative 42. Second equation, I'm going to multiply everything by 5. 5 times 3x is 15x. 5 times 6y is 36y. So, sorry. 5 times 6y is 30y. And then 5 times 6 is 30. So I'm going to work with these two new equations. The difference is now that I can get rid of the x's. And how am I going to get rid of the x? I'm going to subtract. I'm going to go equation 1 minus equation 2. So if I do 15x minus 15x, look, these two go away. 12y minus 30y gives me negative 18y. You have to be careful. Negative 42 minus 30 is negative 72. You will have a calculator. Okay, so, and then we're going to divide this by negative 18. Divide this by negative 18. Negative 18 and negative 18 gives me positive 1, or 1y. And negative 72 and negative 18 gives me positive 4. So y is 4. Now that I know y, you can pick any of these 4 equations, substitute for y, and figure out what x is. So I'm going to pick what I think is the easy one. I'm going to pick this guy here. So y equals 4. So my equation is 3x plus 6y equals 6. Now I replace the y with 4. So I get 3x plus 6 times 4 equals 6. 3x plus 24 equals 6. So it's just a two-step equation, minus 24, minus 24. That goes away. We get 3x equals negative 18. Divide both sides by 3. X equals negative 6. So now we have the point of intersection, negative 6, comma 4. So that's our answer. So again, on the graph, right, there was 2 lines. I don't know what they look like, but I know that they meet somewhere here. There's 2 lines, and they meet over there. And that's the solution to both. So we're going to check. We're going to take this point. We're going to use negative 6 and 4 and plug it in equation 1, plug it in equation 2, and make sure they both work. So the first equation, 5x plus 4y equals negative 14. So I'm going to use the point negative 6, 4. So it's 5 times negative 6 plus 4 times 4 equals negative 14. 5 times negative 6 is negative 30. 4 times 4 is 16. Does it both sides equal to negative 14? Yes, it does. So this point worked for equation 1. So this one is good. Now, do the same thing for the second equation. 3x plus 6y equals 6. I'm going to plug in again. 3 times negative 6 plus 6 times 4. 3 times negative 6 is negative 18. 6 times 4 is 24. And you indeed get that 6 equals 6. So this point right here, negative 6, 4, right? The point of intersection of the two lines satisfied equation 1, satisfied equation 2. That's it. I mean, that's not, I don't know what else. Then the other one is by graphing, right? So here we have an equation. And you want to graph. So they're both already written, right, in the form that we like, right, where we can automatically recognize that that's my slope, and this guy is my y-intercept, right? So easy when it's written in this format, right? You don't have to switch anything, you don't have to do anything. And I'll do one more problem after this where they're not written in the slope-intercept form. All right, so the first one, and let me take the first one apart and I'll write it over here. Y equals negative 2x minus 4. So for the negative 2, I'm going to put it over 1. Now, my negative 4, this guy right here, is my y-intercept. That line that we're about to draw will cross the y-axis here. 1, 2, 3, 4, right here. We can tell by the slope, right? Do it again. It's a negative slope, so my line, we know that it's going to cross going down like that. Okay, so we need to find some points. So you know that the slope is negative 2 over 1. So this, the top one is a change in y. The second one is a change in x. So I don't know, I put arrows like this. So to remind me, it's going to be 2 up and down. The movement up and down is going to be 2, and the left and right is going to be 1. So if I go 2 up, I'm going to go 1 left. Right, remember, up and down is 2, left and right is 1. So from here, I'm going to go and get another point. I mean, you only need 2 points, but if you want more points, just to make your line a little bit here. 2 up, 1 right, 2 up, 1 right, 2 up, 1 right, and we can do the same thing at the bottom. 2 down, 1 left. Sorry, 2 down, 1 right. All right, so we have tons of points, more than we actually need. Now we're going to use a line. Connect the points. Wish mine was better. There you go. Arrow, arrow, give it a name. This is y equals negative 2x minus 4. Yeah, that's it. And then my other equation, so let me do the second equation. Y equals 4x plus 2. What do I know? Well, I know my y-intercept is positive 2. Let me change colors over here. So I know this line is going to cross the y-axis at here. What else do I know? I know my slope is positive. Look, positive. So I know my slope is going to go up like this. Right, from left to right, it's going to go up. And we have 1 point. We need a few more points, just one more. So the slope, let me bring that down here. It's 4, and we're going to put it over 1. So when you count up and down, you're going to do 4 units, and when you count left and right, you're going to do 1 unit. So let's count. 1, 2, 3, 4, and we're going to go right 1, right? Because if we go left and we connect the dots, the line is going to go down, and we don't want that. We actually want the line to go up because it's positive. So 1, 2, 3, 4, 1 to the right, 1, 2, 3, 4, 1 to the right. Then 1, 2, 3, 4, and we have, look, right there. This one, I'm going to make it a pink or purple, right? Different than the red and blue. That's our line. That's our point of intersection. 1, 2, 3, 4. All right, that's where those two lines meet. So let me. All right. Okay. Arrow, arrow. This is my line. Y equals 4x plus 2. And what's our point of intersection? The point of intersection is right here. And this point is negative 1, comma, negative 2. That point is the only point that both lines share. So now we're going to check. So I'm going to use the point -1 and -2 in equation 1, which is y equals -x minus 4. And I'm going to use it in the second equation, y equals 4x plus 2. So I replace x and y values with -1 and -2. So y is -2 times, and x is -1, right? Minus 4. Let's see if that's true. So -2 times -1 is +2 minus 4. And 2 minus 4 is indeed -2. So for equation 1, it worked. For equation 2, again, y equals -2. 4 times x is -1. And then plus 2. -2, 4 times -1 is -4, plus 2. And look, this point here satisfied both equations. And that's how you know we're correct. You should always do your check. I'm going to do one more. Just let me find one online. What are we doing here? Systems of equations, graphing. One that maybe there's a little bit more work. That was pretty simple. No. A second. I'm going to erase everything. I'll do one more. Okay. I think graphing though is the easier. Well, is it the easier? Alright. So let me ignore this. Write one new one. 4x plus y equals 2, and then x minus y equals 3. So let's do that one. Alright, so neither of these equations are in the format that I like, right? Which is y equals mx plus b. So we're going to switch these two equations so that it looks like that. Equation 1, need some here. So 4x plus y equals 2. So I want y by itself, right? So we're going to write in terms of y. So I'm going to get rid of 4x minus 4x, y in the middle, minus 4x on the other side. That goes away, and I'm going to get y equals -4x plus 2. Now, that I can work with. So this equation, I'm going to rewrite it as y equals -4x plus 2. Second equation, x minus y equals 3. So again, I'm going to rewrite it. So let's put the wrong way. Minus x over here, minus x over here. I get -y equals -x plus 3. Not done yet, because that y is negative, so I'm going to divide everybody by -1. -1 and -1, because there's a 1 here, right? So that becomes y equals, right, -1, -1 goes away. And this becomes positive x, and then minus 3. So the second equation becomes y equals x minus 3. And those are the two we're going to graph. So let me make a line to separate everybody. All right, going back to the first equation. My y-intercept is 2, so I go here. Right, so that line is first of all, it's a negative slope, so it's going to come like that, right? But it's going to cross this guy here. And my slope is -4, so let me pull out the slope. So -4, and we're going to put it over 1. Again, my arrows up and down, left and right. So up and down, we're going to go 4, left and right, we're going to go 1, right? So let's go down. 1, 2, 3, 4, 1 to the right. 1, 2, 3, 4, 1 to the right, right? Because, like I said, when you connect the dots, it has to go down from left to right. So going up, 1, 2, 3, 4, we're going to do the opposite. There we go. We have enough points. So get a ruler. All right, so let's give this guy a name. y equals negative 4x plus 2, arrow, arrow. And then the second equation, well, in front of that x, there's a 1, right? Change colors. So first of all, our y-intercept for this guy is negative 3, so it's going to be 1, 2, 3. That line is a positive slope, so it's going to be crossing up from left to right. So it's 1, I mean the slope is 1, and then we're going to put that over 1. So up and down, so let me take that right over here. So up and down, you're going to count 1, left and right, you're going to count 1. So 1 up, 1 to the right, and there we go. 1 up, 1 to the right, 1 up, 1 to the right, or 1 down, 1 to the left. And right away we see where those two lines will meet. Right? So the point of intersection from here looks like this guy over here. Put it in red. And that point is 1, comma, negative 2. So that's our solution. That point exists on both lines, which means it's going to be solution for both lines. All right, so we'll do a check. Take equation 1, and it doesn't matter here. You want to take this version or the second one, it doesn't really matter. Let's use the second one because that's easier. Y equals negative 4x plus 2. And I'm going to replace the y and x with 1 and negative 2. So that's going to give me negative 2 because that's y. Negative 4 times 1 plus 2. Times. So negative 2 equals negative 4 plus 2, and that gives me negative 2. So equation 1, check. Equation 2, y equals x minus 3. So again, replace the y with negative 2 and the x with 1. You should get the y is negative 2, x is 1, minus 3, negative 2 equals negative 2. And again, you can tell that this point right here satisfies equation 1 and equation 2. All right, so yeah, we have one more. The inequalities. Okay, so I love inequalities. So fun to graph. Graph the same way. Right, we graph the same way, except that it's not a point that's going to be a solution, but rather a region, right? So let's take the first one. First one, we already know the y-intercept is positive 2, so right here. Our slope is 1 over 2, so let me write over here, and I'm going to put the arrows so that you remember. Up and down is 2, left and right, you're going to count 2. So up 1, right 2, sorry, right 2. Why am I going right? Because it's positive slope, so when you connect the dots, that line should be going up from left to right. So, right, you don't want to go. So you can get as many points as you want, right? Or you can just there. We are going to right there. Ta-da, ta-da, give it a name. Y is less or equal than half of x plus 2. Now we gotta do our test, right? And if you can't, you don't have to do a test with 0, 0 like we were doing in class. But when you can, I would suggest because it's so easy, right? So we're gonna test this point here, 0, 0. If it works, then this whole region is a solution to this graph, to this line. If it doesn't work, then you don't want that side. We want the other side, right? So test 0, 0, so we get 0 less than 0 plus 2. And is that 0 less or equal to 2? Yes, it is. 0 is definitely less or equal to 2. So this, any point in this region, and you can try it out. Pick any point you want in this region and plug it into this equation, the first equation. You will see that they will all satisfy the inequality. Now we're going to have to graph the second one. Second one is y. I'm going to put this over 1. Okay, y is negative 2x minus 3. So that's a negative slope. And it has a y-intercept of here. That line is going to come down. Right? It's going to be in that direction from left to right. So the slope, let me put it over here, negative 2 over 1. So when you count up and down, you count 2. When you count left and right, you count 1. So from here, count 2, up and down, right? 1, 2, and we're going to go right. And the reason we're going to right is because when we connect these two, the slope is going to be coming down. So there, there. All right, so. And this one, remember, this one we use a solid line, and this one because the line's not included, we're going to use dashed. Okay. But do we have dash? Yes, I do. Connect these. Okay, so now I'm going to change colors to blue. We're going to test 0, 0 again. I'm going to test 0, 0. So we're going to go either this side of the dashed line or this side of the dashed line. We have to decide, and that's some reason we want to test. So let's test 0, 0. Replace y next to 0, so we get 0 less than 2 times 0 minus 3, and 0 is less than negative 3. Is that true? Is 0 less than negative 3? No, 0 is greater than negative 3. So the point where 0, 0 is to the right of the dashed line, so we don't want that area. We actually want this, right? But this side, any point on this side of the dashed line satisfies the second equation. Now, you will notice that there is a region here where the red and the blue intersect, and points in this region, which I'll use purple. So if you select any point in this region, it will satisfy equation 1 and inequality 1, sorry, and equality 2. Okay? There was a puzzle I think I wanted to do. Oh my god, please let this be recording.